Hello everyone. This video will help you to understand better about triple integrals in detail. So, what is meant by triple integral? When we have the integration to be performed for three variables, then you refer it by the name triple integral. Now, we have already seen double integral. Now one more variable is going to get added. So we will be dealing with, say, three variables x, y and z. So we are going to integrate a function of three variables. Now when we have three variables involved, this function x, y, z get evaluated with respect to dx, where y and z will be treated constant temporarily. Next followed by dy, treating the third variable as constant, and then followed by it dz. The order of evaluation is again in general to be the same as your double integral. The inner integral gets evaluated first, followed by it the next integral will be evaluated, and then last you will have the third variable to be integrated. So the order of evaluation will always be from the inside to the outside. So first integration will be done first, second, and then the third, inside to outside. So this is the rule of evaluation. And the second thing to keep in mind is always the variable limit will be evaluated first, and then last will be your constant limit. So first preference of integration is always given for variable limit, and then the last preference is always given to the constant limit. Now how to fix the region of integration and fix the limit for integration of the triple integral is going to play a vital role. Now say suppose we are going to have a problem where we will have to evaluate triple integral f of x comma y comma z with respect to dx, dy, dz, and it is bounded by x equal to 0, x equal to a, y equal to 0, y equal to b, z equal to 0, z equal to c. Now we notice that all the limits present over here are constant in nature. When the limits are all constant, then we can keep in mind the rule, the order of integration is not fixed, or you can say that the order of integration is immaterial. That is, you can integrate whichever you feel the variable to be taken first and evaluated. So by this we mean x varies between 0 to a, the function f of x comma y comma z, dx to be integrated first, then followed by it you can have your y to vary between 0 to b, with respect to dy you integrate it, and then you have your z to vary between 0 to c, dz you integrated. This integration will be exactly the same as you can now take the preference of y first, y varying from 0 to b, f of x comma y comma z. So y you have taken first, so dy first, and next you can take your z between 0 to c, so dz, and last you can integrate your x between 0 to a, dx. So when the order is going to be, the limit is going to be in terms of constants, So the order in which you evaluate is not going to matter. It is not fixed. You can integrate it by whichever way you are comfortable. So this is about the constant limit. Now the rule is not going to be the same. It is going to be different when you have variables involved in it. So whenever we have variables involved, then how to deal with it. Okay, so next page. Say suppose we have integral 0 to a 0 to root over a square minus x square, 0 to root over a square minus x square minus y square, f of x comma y comma z, dx dy dz. Say suppose we have to evaluate this problem. Now don't blindly go by the given order over here and integrate it. We need to first verify whether the order, because this is in general we write dx dy dz is going to be a general format, but does it suit our formula or our problem which has been given to us is what we need to consider. So how many variables are involved? X, y, z. So let us consider the first limit. What is the first limit? 0 to root over a square minus x square minus y square. What are the variables involved over x and y? Now keep in mind that a limit cannot be the variable itself. So I cannot have x to be the limit of x itself, or y to be the limit of y itself, or z to be the limit of z itself. You can understand it in the way like poles are going to repel each other and unlike poles attract each other. So x and x are like variables. So you cannot take x as the limit of x itself. Y and y are like poles. So y cannot be the limit of y itself. Z and z are like in nature. So they cannot be the limit of one another. So when x and y are involved, you cannot have x to be the limit of x. You cannot have the y to be the limit of y. So what has to be taken as the limit? It has to be taken as the limit of the third variable z. So you fix this as dz varies from 0 to root over a square minus x square minus y square. So the order now changes as, which is integrated first? dz. So dz will be integrated first. So followed by it, then comes the next variable. What is the next variable you have over here? The next variable is 0 to root over a square minus x square. Of the three variables, one has already gone, so you have just two variables x and y left out. Now this involves x. Can this be a limit of x itself? No, we know that x cannot be the limit of x itself. So this is ruled out, hence you go for the second variable. So this has to be the limit of which variable? It has to be the limit of y. So y varies between 0 to root over a square minus x square. So which gets evaluated second? dy gets evaluated second. And last but not the least, the constant term comes into play. What is the constant term? Z has gone, y has gone, the left out is x. So x gets evaluated between 0 to a, and then dx will be the order of integration. So keep in mind, when they give the problem to you in question, the question will be in general stated as function of dx dy dz. But before you evaluate, please do check whether it suits the limit given for you. If it is not going to be the right order, please rewrite it in the right order and then start your evaluation. So this is with respect to the variable limit first, and then followed by it the constant limit. Now say suppose we have been given a space for evaluation, and in which case we will have to fix the limit of the integration. So say suppose I have triple integral over v, the function of x comma y comma z dx dy dz has to be evaluated over the space which is bounded by the coordinate planes and the sphere x square plus y square plus z square equal to 1 and is contained in the positive octant. Okay, so how to fix the limits now? Now we know that whenever we have two-dimensional space, you have x, you have y, so it is now divided into 4 quadrants. So this is the first quadrant where you have both positive, that is x is greater than or equal to 0, y is greater than or equal to 0. When we have 3 variables, an x, a y and a z, the total space is now divided into 8 octants. So out of it there will be one plane or one space where you have x to be greater than or equal to 0, y to be greater than or equal to 0 and z to be greater than or equal to 0. So which plane has, which octant has all these 3 positive is the first octant. The positive octant has all the 3 variables as 0. So now they say the space is going to contain the sphere in the first octant or the positive octant. So whenever we have been given this word positive octant, we now have the limit as x is equal to 0, y equal to 0, z equal to 0 for your positive octant as the lower limit. So this becomes the lower limit. And how about the upper limit? Now take the function x square plus y square plus z square equal to 1. If I want to fix it in the direction of x, then x square is equal to 1 minus y square minus z square. So x will be plus or minus root over 1 minus y square minus z square. But since we are in the positive octant, the negative sign will get off, and so we have x is equal to root over 1 minus y square minus z square. So x has gone. Now the second limit for y. What is y? Y square plus z square is equal to 1. Y square will be 1 minus z square. So y will be plus or minus root over 1 minus z square. So since your negative axis is ignored, y will be from root over 1 minus z square. This is my lower limit. Y has gone. What is the last variable at? Z square is equal to 1, z is equal to plus or minus 1, minus goes off, z is equal to 1. So this now becomes my upper limit for x, upper limit for y, upper limit for z. So the now problem turns out as x varying from 0 to root over 1 minus y square minus z square, the function x, y, z. With respect to x first, so dx first. Next, y varying from 0 to root over 1 minus z square, so dy next. Next, z varying from 0 to 1 dz next. So this is the way in which the function gets evaluated whenever you have the quantity to be variable in nature.